What's the first thing that this line says? What's it say? Okay, I'm not hearing everybody. What does it say? Okay, now I heard you. I will not remind you about this. I will not remind you. If you don't check it, regardless of whether or not you got the right answer, I will take off a point. Square roots have to be checked. Why do they have to be checked? Because sometimes we get negative values even though we have a solution. So sometimes you'll have no solution. Sometimes if there's one answer, it'll work. Sometimes if there's two answers, one will work or they'll both work. Okay? So this is a little labor intensive because you're having to check your solutions. Now you got to show me these checks. These checks can't just be done in your head and kind of go, oh yeah, this one works, or oh no, this doesn't. You've got to show me the work. Okay? All right, so we'll start out with an easy one. Okay? We say the cubic root of 2x plus 7 equals 3. You always want to isolate the root as much as possible. In some cases, when we have two roots, that's hard. But if there's only one root involved, keep the root on one side and everything else on the other. Okay? How do we remove a cubic root? What do we do to that side? You cube it. So if we cube this side, we have to cube the other side. And so then this gives me just 2x plus 7 is equal to 27, which means 2x is equal to 20 and x is equal to, do I have to check it? Not cubics. Not cubics, just square roots. Okay, so the cubic ones are the ones that you don't have to check. Just the square roots. I won't do quintics, but if I did, the answer would be yes. Even roots. And even roots always have to be checked. Okay, I'm going to do this you try down here. Okay. This is the square root of 10x plus 9 is equal to x plus 3. So how do I eliminate the square root? Square it. Haley, what are you doing? You're just now getting it up. Okay. Didn't you have this? Oh, bummer. Okay. What am I left with on the left side? Please, who can tell me what I'm left with on the right side? What is it? Yay. Right, because it's x plus 3 times x plus 3, so we're squaring. And don't forget your middle term. Okay, so that means that obviously if we're trying to solve, we have to set it equal to 0. So I'll set 0 equal to x squared minus 4x. My 9's are going to drop out, aren't they? So how do I solve this problem? By doing what? Pull out an x. X minus 4. So what does x equal? And? Good. Do I have to check this one? Why? Because it's a square root. Okay. So we're going to check it. Here's how I want you to check it. You start by writing the original problem and inserting whatever one that you're going to use. I'm going to check x is equal to 4. So I'm going to do 40 plus 9 has to equal 4 plus 3. Does the square root of 49 equal 7? No, it doesn't equal plus and minus. Because it's not x squared is equal to 49. It's just the square root of 49. Okay? So this works. And then we check 0. And so is the square root of 9 equal to 0 plus 3? Sure is. 3 equals 3. You got to show me that last step. Don't just do it in your head and go, oh yeah. The reason is you're going to be getting into some proofs next year. You've got to show me that final step that the left side equals the right. So Both of these are solutions. They both work. So sometimes both of them will work, sometimes none of them will work with square roots because my checks worked. Okay. All right, let's try this one up here. Let's go back up to this one. You do that one yourself. Does this work? Do they both work? I get the square root of, I get 7 and negative 2 are my solutions. Would you agree? Yes? So 7 works. But if I use negative 2, I'm going to get the square root of 1. Does that equal negative 1? No. So this solution doesn't work, and this is the only one that does work. So you need to clearly indicate which one is your solution, and if there isn't one, then put the empty set. Yes? Because I'm not starting out with this. I'm not starting out with an equation where I'm solving for x. I'm simply telling you take the square root of 1. And if I tell you to take the square root of a number, it's only going to be the positive value. It's when we're dealing in an equation and we're figuring out and we're taking the square root to get to our x, that's when we get positive and negative values. Okay? Just a little side note. Let's say my check said negative 11 equals square roots of negative 11. That's still not okay because I'm not allowed to have that negative value underneath the square root. So if you get a check that says the square root of negative 11 equals the square root of negative 11, that is really not a solution. Does that make sense? Okay. Okay, the next one. What am I going to do in this one down here? Square roots of 2x plus 5 is equal to square roots of x plus 7. Square both sides. This is an indication or an example, guys. Don't get the square roots on the same side. Okay? You need to, in all cases, this case, look at this case, and look at this case. When I've got two square roots in the same problem, you never want to solve them and having the square roots on the same side. You always want them on opposite sides. It makes it easier to work with. This case is easy. When I square both sides, I get 2x plus 5 equals x plus 7. Would you agree? Which then leaves me to say, well, that means x is 2, and guess what I need to do? I have to check it because I'm dealing with the square root. And so when I deal with the square root, I'm going to say the square root of 9. Does that equal the square root of 9? It sure does. That's a good enough check. You don't have to take it down to 3 equals 3. All right, the next one becomes a mess. When I square a side, I square the side. I don't square the individual terms. So the left side, or the right side, becomes simply x minus 2. Agreed? But the left side, I'm going to expand it out. It's the square root of x plus 6 minus 2 times square root of x minus 6 minus 2. Right? So we got to remember that there's a middle step in there. There's a middle term. Okay? So we FOIL. We take the square root of x plus 6 times itself, and what does that give me? That part's easy. If I take the square root of x plus 6 times negative 2, what do I get? And then when I take this negative 2 times that term, I get the same thing, right? Would you agree? And then I take the negative 2 times itself, and I get plus 4, and that equals x minus 2. No. Why would it be? I'm not multiplying by conjugates, Grace. I'm taking that term and multiplying it by itself because I'm squaring it, right? So what I really have on the left is x plus 10 what? What is this going to give me when I combine it? Exactly. So I haven't eliminated my roots yet. I still have a root in the problem. And so what we do is we go through the process again by isolating the roots. So this x gets moved to the other side, and in this case, what happens? They cancel. All right, here's a common mistake. Can I take the 10 minus the 4? No. All right, this negative 4 is attached to this root x. Okay, so I move the 10 by subtracting it. Would you agree? And now I'm left with negative 4 root x plus 6 equals negative 12. I would divide because I haven't isolated my root yet by negative 4. But here's the trick. If this negative 12 divided by negative 4, let's say it didn't come out evenly, and I get a fraction, just take that 4 back over to the other side. And when you square the left side, remember to square the negative 4. Does that make sense? But in this case, it works out nicely. I can divide, and I just get 3. And so I'm left with root x plus 6 equals 3. And then what do I do? And so x plus 6 equals 9. So x is equal to 3. And then I get to do what? Yes. And I check all the way back up to this problem right here. So I'm going to say the square root of 9, I don't know, what was it? What was that here? X minus 2, so 3 minus 2. That's not right. This is minus 2 right here. So this is going to be 3 minus 2, which is 1. This is going to be square root of 1, which is 1. And so it checks. How are we doing? Okay, next page. Let me get through all of these, and then if I have a chance, yes, I'll generate one for you, okay? All right. Here we go. We have 3x to the 3 halves equals 375. Is this coefficient part of being raised to the 3 halves? So get rid of it. X to the 3 halves now equals 100 and, I don't know what it is, 25. Okay. This is the square root and cubing it, right? So we can do this in a nice step. What power would I raise both sides to so that I am just left with x to the first? 2/3, exactly. To the 2/3 to the 2/3. So we know that when we raise a power to a power, we multiply those values, those exponents, correct? And so then over here, that's why I just get x on the left. And so here I'm going to take the cubic root of 125, and then I'm going to square it. So 5 squared is, and then this is a square root problem, isn't it? Wasn't this a square root problem? So guess what we do? We check. Okay. And so we'll say 3 parentheses 25 to the 3 halves has to equal 375. That's 3 and the square root of 25. We're going to square this or cube the square root of 25 after we've taken the square root. That's 3 parentheses 5 cubed, 3 parentheses 125, 375. Don't get lost in your math work. Do it step by step. Okay? All right, one more. All right. This is going to be your, some people are going to try and do this. Do we want to? Can we distribute the exponent? Have we finally learned that we can't do that? Okay, good. So I want to get to that x, and it's inside parentheses being raised to the 4/3. So how do I remove the exponent? Do it to the 3/4. So I'm left with x minus 4 here is equal to the 4th root of 81 cubed. What's the 4th root of 81? This is an equation. Plus and minus 3. And I'm going to cube it. So it's plus and minus. And so I'm going to get x minus 4 equals plus and minus 27, which means x is equal to 4 plus 27 and 4 minus 27, which tells me that x can equal 31 or negative. And what do I need to do? Check. Check. There is a lot of checking. That's why I said this is labor intensive. Okay. So 31, so we've got 2 checks. 31 minus 4 is what? 27. And so the cubic root of 27 is 3. And if we raise it to the 4th power, we get 81. And then if it's negative 23, what's the cubic root of negative 28? Hold on, no, the negative, you can't see? Who can't see? Okay, is that better? Okay. It's the cubic, when we do negative 23, we're going to get the cubic root of negative 27. What's that? And when we raise it to the 4th power, what do we get? And does it equal 81? Sure does. So the left side equals the right. Okay. So Emma, with response to your question, let's say I got down to negative 3 square root of x equals 7. It's not to my benefit to divide by negative 3 because it's going to give me a fraction. I don't want to work with it. So when I square this side and I square this side, this gives me 9x. I'm just saying don't forget to multiply and square that 3. This gives me 49. You know, I'm still going to get a fraction as my final answer, but at least this is easier to work with when I try and solve. All right.